And well, my goal this training is that you will learn how EarthMap works and what are the possibilities that you have to access information through EarthMap, and also even to think on your own projects, how EarthMap could be used or how it could be improved to actually help you with these irrigation projects in Serbia. So let me share my screen first. I have a very short presentation that we can use to start to present EarthMap, and then we'll do a small demo afterwards, and of course will be time for questions. Whenever you have a question or you have any comment, just raise your hand or put your question on the chat, whatever you prefer. And yeah, feel free to interrupt me if you want to. All right, let me share. Okay, it's working. Sorry. My computer is not collaborating. Oh, sorry. You guys are looking at my slideshow or the other way around, right?
The other way around.
Sorry, my
Just
computer.
go on display settings and.
Yeah. Wait a second. My computer is just completely frozen. Just a second. Let me restart the PowerPoint. Sorry. Sorry. Como dicen in Spanish, you say in the house of the blacksmith, they use a wooden spoon. So, you know, this is what happens when you're a computer engineer and you need to show a simple thing online. Doesn't work. PowerPoint. Okay, let's try to restart now. Okay, not working. Again, same thing. So I'll do, maybe I just don't do the presentation. Sorry. Screen. Anyway, more or less this works, no? You can see there's some issue that I cannot show my presentation correctly. So you can at least see the slide, no?
No, we don't see the slide.
No, we don't see anything. We see your Zoom page, Alfonso.
Now?
Yes, now we see it.
Okay, sorry for the technical issues. So anyway, back to topic again. So I always start all my presentations, both for EarthMap and the other project that we have in FAO that I work with, also it's called Collect Earth. I don't know, in Serbia, well, in Serbia, they actually collected hundreds of thousands of plots of data with the Collect Earth, but probably you're not involved on that because that was done by the Forest Service, okay? But anyway, I always start my presentation saying that I'm a computer engineer. All right, I'm not a hydrologist, I'm not a forest or agriculture expert. I'm a forest engineer, I'm a computer engineer, and what I do is to try to always make the access to data and information easier for the user. All right. So if you hear me saying something strange about irrigation, well, it's not my topic, you know, or about the agriculture. But in Google Earth Engine, sorry, Earth Map is a collaboration between FAO and Google. Within Google, there is an organization called Google Earth Outreach. I guess you all know Google Earth, which is the, I don't know, a tool that they have had in Google for the last, I think it's 15 years, so that you can visualize all the satellite imagery anywhere in the world. So as part of that group, there is also another service that was developed already, I think it was 8 years ago. And it's called Google Earth Engine. And Google Earth Engine is a cloud service where Google puts together all of the freely available satellite imagery and freely available GIS data, population data, all type of geospatial data that agencies such as the NASA or the European Space Agency or the USGS, JAXA, the Japanese Space Agency, they all provide data for free. Well, it's not for free because they pay for it, but I mean, they distribute it to anyone that wants to use it. And of course, this big issue right now is that there is so much data that is very difficult to actually make any sense of all the data, because anyone that tries to download imagery, for instance, for Serbia, if you were going to download yourself from those services, from the USGS or from the European Space Agency, to download all those images from the Sentinel or the Landsat satellites would take you months, perhaps, to download for a full year, or at least weeks minimum. And then, of course, even you have the data is very complicated to use. I guess you have already heard this from other presentations. You know, right now the issue is not so much the access to or the presence of the data, is about the processing and the analysis of the data. So what Google Earth Engine does is to give us interface so that programmers or geospatial experts such as me can access those data sets, like as I was saying, like this digital elevation model, land cover model, surface models. You can access those data sets directly through the Google Earth Engine servers. So they store all of those data sets are stored in the Google, the same thing than YouTube, but the same place that they have the YouTube videos, they will have the Landsat or the Sentinel archive. And not only you can access those images, but you can also use the Google Earth Engine service to process them, to do things with them, to visualize them or to analyze them. Okay, so this is, I don't know, lots and lots of data that is available. But there is a problem with Google Earth Engine. Anyway, you're going to hear me speak a lot about Google Earth Engine, right? So there's a problem with Google Earth Engine is that for most users, even though this is a very powerful tool because you can do so many things, it's very complicated to use. Well, it's not complicated to use, but let's say that an average user that does not have a good understanding of software development or programming, and then also not only you need to understand programming, but you need to like understand the concepts behind Google Earth Engine and how Google Earth Engine works. Let's say it's a stretch for most users to actually be able to use Google Earth Engine. In this slide, what you see is the Google Earth Engine editor, code editor interface, where you see here in the middle, there's the script, let's say the code that allows us to access the data. And then you have also access through this code editor to some information, some documentation. You can also visualize some of the analysis there, and also visualize or view the images. This in this case is an surface digital elevation model all right? But anyway, in order to do this simple analysis, to have a profile of the elevation and slope of a line within the US, this is the west of the US, you will have to know how to write all this code, which is not, it's not banal. It's something that is not trivial. You need to really put some time on that. So what we have tried to do in FAO is to simplify, to provide the users with the power of Google Earth Engine, so that you can visualize the images. But most important than that, because I mean, looking at maps is always nice, and you know, it gives you an idea of things. But more than just visualizing maps, Earth map is also able to give you quite good and accurate zonal statistics on the areas where you're interested. So in Earth map, we are letting the user look at maps on different themes. So for instance, this is the themes that they have been aggregated, the layers or the maps into. So you have climate, fire, forestry, your social, physical, hydrology, land cover, satellite imagery. So lots of themes, and within the themes, you have the imagery or the maps that you can access for Earth map. So you can visualize them in the map. And then once you get your area of interest, for instance, in this case, in this image, this is a province in India called Punjab. You can start running external statistics on that. For instance, seeing what is the total area of the total barn area per year, or the barn area per month, or the average barn per month, the average barn area per month, like this in this case of this slide. Okay. As I said, we have a lot of different thematics, right? So the main one, for instance, for any kind of analysis is, of course, the climate theme, where we have data on precipitation and temperature. Especially also we have data in, for instance, the number of days above or below a threshold temperature, above a threshold precipitation. Anyway, there is a lot of different data on climate. We have in hydrology, we have data on runoff and on curve numbers and soil types. Land cover data, land cover maps on different providers, from the European Space Agency to the MODIS or to other land cover maps. Then data on forest change and forest deforestation, or satellite measure deforestation. And within agriculture, well, we have some data as well. In agriculture is not very strong right now because we only have data on the crop extent and the change on the crop extent. But of course, we are looking always forward to have more data on agriculture or more data on country level agriculture. So let me just show you from, if there is any question, as I say, stop me, or there is anything in the chat. I don't really see the chat, but anyway. I think we can go directly right now, and then, for instance, just go into this link of Earth maps. So I just show it to you very fast, because I feel like the theory of Earth map is pretty simple. As I say, it's very, okay, let me just log out first. The theory of Earth map is very simple. It's basically a way to access the Google Earth Engine without coding, it says here, no? So once you go into earthmap.org, this is our website, right? You see some information on what is Earth map and so on, and then you have some access to some documentation. But the most important thing is you can access the actual map through this login dialog. Okay, this is important. Well, access is free for anyone. All right, so this is just a way to to keep a little bit on track of some things that I'll show later. So you can log in with a Google, with a Gmail account, or you can just sign in with any other email, or just you can continue anonymously if you don't want to put your email. It's more convenient to access EarthMap if you put your email, because if you put your email, later you will be able to access the polygons that you will upload for your projects. So this is one nice thing about EarthMap, that once you upload the areas of interest for your projects, for instance, you have an irrigation project, you can upload that irrigation project and it will remain here within your areas of interest. All right, so like this will be like some projects where we have some boundary files that we have uploaded. I will show you that. We can practice that later. Anyway, when you enter EarthMap, you can see the satellite view, or you can look at the map view. Sometimes the map view is a little bit more clear when you want to look at boundaries, actually, than the satellite view. Okay. And here in particular, we see that what we have done, the first step in EarthMap is always to select your area of interest. We have multiple types of area of interest. We have country, we have some project area of interest, but the usual thing is that we have countries. We have most countries in the world. I think we have almost all of them, except for the small islands in the Caribbean. I think we are missing some of those, and in the Pacific. But anyway, the first step will be to load your country. In this case, will be Serbia. You can even write Serbia there, and it will get there. And then automatically you get the country boundaries, right? Well, the international boundaries, actually, these are the official ones that we had. Maybe we'll have to check, actually. And then you have regions as areas of interest. We also have national parks. National parks is not perfect because, as you see, some of them are actually just like touching Serbia. It's not really in Serbia, or I don't know. They are not amazing. And also, it only includes certain types of national parks. So this is something just added not too long ago. But anyway, there is a couple of them that are right. And then we have the basins. So there are 12 levels. So sorry, 7 levels that we have here in EarthMap. So it's from something called the WWF HydroSets. It's a global product that uses digital elevation models to calculate basins at different levels. Okay, and they have a system also how to kind of link from a high level to a low level. So the level 6 is quite a high level of basins, while level 12 you go into much smaller basins. Okay, and this is the smallest the smallest basin level that we have in EarthMap. Of course, if you have your own basins or your own whatever boundaries for your projects, you can upload them here. Close. There is a button to upload your areas. Okay, and you can draw it or you can upload it. When you upload it, you can upload the KML, a GeoJSON, or you can also upload a shape file. If you have a shape file, you have to put it into a zip. So because a shape file includes multiple other files, so you have to put everything together into a zip, and you can upload that file. And then you will end up here with your project. For instance, this one. If your project was just this, then you could access it directly through this menu. Okay, so this is areas of interest. Let's go to the regions. We have selected this one, I think. Now we just reverse no key that one. Okay, and you see that when you click, you can click on the boundaries. Okay, and this will be important later because when you click on an area is, oops. My computer is frozen again. Okay, no. So when you click on an area, you will be able to run statistics on the area. You will be able to analyze the area. All right. So those are the areas. Then the next step, as I said, is once you have your area, you have your area of interest that you want to do your analysis and so on. Well, even before, anyway, you.
Alfonso.
Yeah.
Sorry, just to check that if there are questions from colleagues and if they all manage to open Earth map or if any have difficulties, just to be 100% sure they can follow up clearly all the explanation. Colleagues, please. Just we put the link in the chat. Try to connect to the browser. I mean to Google Earth. Sorry, to Google Earth, to Earth map. And if you have issues, don't feel shy. Just raise your hand or put it in the chat. Sorry, Alfonso, to interrupt you. Please go ahead.
But anyway, but we can do the access later. Yes, just for it's good if they just look at the workflow. I mean, I think this will be quite fast, and then we go into. But yeah. Anyway, yes. If there is questions, or am I speaking too fast? You guys are good with English?
I think it's the right speed. And if anybody has issues, please also in Serbian, just put something in the chat. We will address it in both languages. No worries. Thank you.
All right. I put the chat here so I can see there is messages. All right. So as I said, now once you have selected area of interest, you can look into what products we have. For instance, we have in agriculture is not that much. The latest one we have is this one, the global cropland extent. Okay, it's not that much for a global. Okay, what I have forgotten to say is that in Earth map, as you see, we have lots and lots of countries, right? So we don't really have the time, except for some requests that come from the countries. If there is a special request that come from the country, then we add those maps, but we don't really have the time to find national layers to put in Earth map. So what we are using in Earth map is any kind of global or at least regional, no, like European or African, no, so that you can use in multiple countries. So regional or global maps, that's what you will find in Earth map. If you are looking for national maps on whatever of Serbia, this is not your place. You will have to go to the Serbian geospatial, I can't remember what it's called, the Serbian geospatial something. I think there was a while ago I was looking at it. Anyway, this is all global products. Although we can accommodate as well national products, okay, national maps. If we know what is interesting, and we know what is going to be used by the users. So I say, for instance, here we have this global cropland extent, which is one of the latest products on the chains on crops, or on crop area or agriculture, which if you don't know what this is, there is an information window, an information button here. You can click on the information button, and it tells you, like an explanation of what this is. Okay, so this is a cropland mapping that was done using Landsat from 2000 to 2019. So you will be able to actually see the difference between 2000, 2004, 2008, and 2019. Okay. Right. So you have these 5 layers. So what was cropland in 2003, 2007, 2011, 2015, and 2019. You can also click on more info here, and it's going to take you to a dedicated, how you say, a dedicated website of the product. Okay. And on the data source, you can also access the paper where this is based on, this product. Okay. So again, if you look at the layers, you have the information window. I'm sorry, everything is in English. I mean, this is really another difficult part when you do a global product like Earth map, that providing translation in all possible languages is kind of difficult. But if you have Google Chrome, I think you should be able, there is a way to just translate everything. I can look at it later. This is a problem for you. How do you do it? There is I know there is a way here somewhere to just translate everything automatically. And maybe it's even appearing already in Serbian for you. Anyway, I look into it later. I cannot remember how it's done, but I've seen it. Many people has this functionality that anything in English is already translated or in other languages. Anyway, so information, you get the information about the layer, blah, blah, blah. Once you click here, so you activate or deactivate the layers, you can have up to 4 layers loaded at the same time, okay? So, but let's just go onto this layer, right? So you can see here the legend, right? This is your legend. It's not like super clear. Actually, these colors are very close together. But let's say if we go to this province of what was it called? Severno. You can see here on the bottom right, when you move the layer, sorry, when you move the mouse, you can see the change on the latitude, longitude where the mouse is. And you can also on the bottom right, you can see the name of the area of interest. So anyway, so if I will go to this area of interest, Severno Banatski, right? I can just zoom on it. And of course, like in any map viewer, you can see the map. You can see how it changes. You can see the colors. And for instance, here, there is some indication that is cropland lost here. It's strange, actually, no? That there is a cropland lost. Maybe it's a, I guess it must be some kind of water or something, no? But anyway, you can see the map. Maybe we can even load the satellite so we can see what is behind that. So you see, according to this map, there is cropland loss. So this is red colors, right? So anything has been lost there. So here on the legend, if you want to see what's behind the map, you can click on the opacity. Okay. You click on the opacity. And then you can see what was behind. I don't know why they say this is a cropland loss. This is a bit strange because it doesn't really look like cropland, but I guess maybe before it was cropland. Well, perhaps it was cropland before, I'm not sure. Anyway, you can use, oh wait, maybe this is too small. This can be seen well, no? In your screen, I hope. Anyway, we have the opacity here to change the opacity of the layer. Okay. Then here you also see okay, most of these provinces are all cropland. No, this is the really productive area of Serbia in the north. Most of the areas are cropland. It's loading, it's taking a little while to load. Right. Is it taking a while to load? Okay. Here, another, just to explain you this stuff, you can again, you see the information window. Just to explain very fast, but a little bit fast the legend so that we can show more stuff later. You can change the year. So you see that some of these products, like this one, has multiple layers, multiple years. So when you click on this date range, sorry, oops. When you click on the date range, you can see what was according to these crop models, through crop area models, what was in 2003, what has been crops in 2003. So you can change the years here, okay? Oops, it's not changing. Yes, it's changing. Okay, I guess there will be not that much change in that region anyway. So, all right, so this is how you saw the layers. you have the information with the layers, the opacity. You can change the years. You can also download the maps. So if I say, okay, this is a really interesting map on the cropland extension in what was the name of the place? Severno Banatsky. So I want to use this on a report, or I want to use it on my own. If you are into GIS and you are using ArcGIS or QGIS or whatever, then you can download the layer. So I could click here and I can download the same image that we are seeing. I can download this as a GeoTIFF. So I can put this on a let's say on a report, on a paper, or whatever you want to put it. Or you can also download it as a GeoTIFF. The GeoTIFF is the version of the image that will be used on a geospatial GIS software. Okay, so you just want to use the image on a report, you download the PNG. You want to use it in QGIS or ArcGIS, you download the GeoTIFF. Okay, so let me just open. Is this, which one is this? The TIFF. Okay, now I want the other one. The PNG. Did I click twice the same one? No, PNG. Yeah. So anyway, here you have the image for that province. So it will be actually clipped to the area that you have selected. If you selected the whole of Serbia, so then it will be clipped. The image of this layer will be clipped to the whole of Serbia. All right. But anyway, maybe I'm going a little bit deep into the functionality yet. So let's see other things that we can analyze here. If I go back to the presentation I made for you, I see that I had already prepared some links. So let's just click on the link, because this is an interesting thing in EarthMap. When you change your layers or change your area of interest or load different things or do statistics, the URL, so this changes, and this keeps all the information about which area you are looking at, which zoom you are doing on the map, what statistics you want to show. So you can actually just copy. If you see something on EarthMap that is interesting and you want to send it to someone, you could just copy the URL. Okay, so just copy this and send it to anyone or put it anywhere as a link, and then that next person will be able to see exactly the same thing that you are seeing in EarthMap. This is very useful for sharing information, for reports, for whatever you want. Right. So again, now we have here in EarthMap, automatically it has loaded this layer. So we have land cover. As I say, we have a whole theme on land cover with lots of different land cover products. Okay. Most recently, we have just added the world cover one. But anyway, as you say, like a lot of the analysis that you will do for any project always starts with the land cover. Again, these are global, most of them global land cover maps. We also have Corinne, which is the European land cover map that is produced by the European Environment Agency. Okay. 6 cooperating countries, which Serbia is one of the cooperating countries. No, so this is one of the best European level land cover maps that you have done by the Copernicus and so on. Okay. So here we can see for this area of what was it, Severnovaki. Okay, so this is the land cover map, right? You have the legend here, so you see that most of this area is settlements or artificial surfaces, and then here you have the agriculture areas, different types of agriculture. Again, this has a lot of land cover classes, so it's actually not so easy to read the legend, no, because it's so many different colors, right? And also the colors are very close together, right? So this is sometimes not very easy to read, right? For that case, here on the right, you see that there are two small tags, and one is for the statistics. It says statistics. The other one is the pixel inspector. Okay, so if I have loaded this layer on Corinne of the land cover, and actually I don't understand which color is this because I don't really see, like I cannot really understand which one of these is. Okay, there's many similar colors. So you can do the pixel inspector. You can use the pixel inspector. Okay, click on your point and click, and it will tell you here that this is a heterogeneous agriculture area. And also, not only that, it also tells you the timeline of the point. Okay, if it has changed or it hasn't changed. Like, let me see if I could find one point that maybe has changed here. Yeah. So for instance, this point here, which is coordinates, in 1990, it was agricultural area. And in 2000, it was changed to a urban area. Okay. So let me just explain about Corinne first, because maybe again I'm going a bit far. Corinne is a product from a land cover product where you have again all these years where there's information. You can change the map, so you can compare how this area was in 1990 according to Corinne. Of course, this is always a model, you know. So like there will be how to say mistakes, and I don't know why, but it seems that today is not loading very well the maps. Okay, so this is the 1990 map where you see this area where the point was agriculture. And if I change to 2018 again, or 2012, for instance, no, this area will have become red. Now, this is how it changed from 2000 to 2012. So this is a nice way to visualize information, no, with the maps, but it's very difficult to do any further analysis on the map, no, because you need to understand like how has it really changed. So for that, in Earth Map, once you click on your area of interest, in this case, this Severnobaki, okay, let's just close. Anyway, this I'll just show you how to do it. We can run here. We have the possibility of visualize layers, right? And in this button here, where it says statistics, we had the possibility to analyze that information. So if I want, for instance, to understand what is, according to Corinne, the change on land cover, I will just go here and put land cover. Here we have all of the different types of land cover products that we have. Again, you will need to know which land cover you want to use, which land cover map you want to use, and you will also need to understand a little bit on the different legends or different classifications. Some land cover maps will be better for different areas. Anyways, we are assuming here that Corinne is one of the most advanced ones. It should be good. So I click on that one. And now that I have chosen that, I can click on process. And what is happening, what is happening is that Earth Map is sending all this information to the Google Earth Engine. Again, what this visualization that we are doing is all based on Google Earth Engine. Earth Map itself, the service of Earth Map is running on the Google Firebase hosting, Firebase hosted functions. So everything is Google based, and the information that we are, the map, the way this is shown is that it comes directly from Google Earth Engine, and as well the statistics are done on the fly. So it means that you could take any area. Right now we are using a province, but you could just take any kind of area, or it could be very small or very big, or it could be just something you draw, or as I showed you before, one of those boundaries that you uploaded, anything. It could be at any level, Earth map will send that area of interest to Google Earth Engine. It will tell Google Earth Engine what you should do in that area of interest, in those boundaries, and Google Earth Engine returns the results. So this means that for any area, we can do the same type of analysis. What we get for Severnovaki here is, okay, a lot of data here. So we can show these graphs, but it's a lot of different classes. So it's kind of difficult to look at it like this. And you have also the information, the land cover for each one of the maps that we have. So we have the 1990, 2000, 2006, 12, and 18 maps. So this is not super easy to look at as a graph. So it's actually easier maybe to look on it on Excel or something like that. I see there is a recent hand that is raised hand by Jordana.
Yes, I have a question. Can we select several regions, for example, before processing?
Yeah, that's a good question, and that's a feature that we have been requested to do for years, and right now we don't have it yet. We will have it eventually one day.
That means if we want to several of a few of them, then we need to have to prepare our boundary and to upload it. Yes.
I mean, yeah, if you wanted to do the analysis of all three together, then you will have to upload that boundary and do the analysis. If you wanted to do like a batch processing one by one, then we don't really have that. Then you will have to do it. Then we have the Google Earth Engine code that can do that. So we have the Google Earth Engine code where you can just tell the Google Earth Engine code, do the batch processing for all of the regions, and it will do it. But in the interface, on the Earth map interface, sadly you cannot do it. And I know this is a feature that has been asked by many people actually, that you can, so you don't have to go one by one. But yeah.
Okay, we can just do it one by one. And if you want, for example, to have two regions at the same time, it's not possible.
No.
No.
I mean, if it's only a few regions, it's not a big issue. If you have like, I don't know, 50 provinces, then it's kind of doing the same analysis for 50 times. It's a bit heavy.
Okay.
But anyway, now when you what's it doing? Yeah. So now that we have the analysis of the area change or area land cover area per each one of the maps, well, you have some options here. Again, you have the information, so you always have a little bit of an idea. Okay, this is a lot of data here, but whatever. And you have a ways to maximize it. You can click here on maximize to make it a little bit bigger. Maybe it's a little bit easier to read. Did you make it bigger? Maybe not so easy anyway. Well, I will make it maybe like this. So this is another way to look at it, but still not super easy to look at it. So then the easiest thing is to just export the data. You click on export. You can export the image, which basically will export this image of the graph. I don't know, maybe a little bit useful, not super useful, I think, if you are going to just have this, because you don't really know very well what how this data is, what is the data, no? But you can export the CSV, which is the most interesting. So you click on export CSV, you see automatically downloads a CSV file. You can open the CSV file. Okay. I have a program called LibreOffice, which by the way is way better than Excel when it comes to CSVs. Excel does a lot of issues with CSV, so I'm strongly discourage you to use Excel with any CSV files, because it's going to really mess up your data. But Excel LibreOffice is not running now. So I have something wrong with my computer today. Or I don't know if it's wrong, a computer with Zoom.
I don't know.
Can you see anything?
No, we see a blank page.
No, there's something wrong with X. But can I just let me see if I can just switch now straight to downloading export CSV. Okay, if I open it, okay. Vale. Program. Okay. I mean, maybe I actually have to open it in Excel. Okay. Let's see if in Excel it doesn't have. Anyway, here it is in Excel. I eat my words. And you have here for each one, for the even you will have that in your the name of the file. The name of the file that you download is already the province name, Severno-Bacchi, land cover, Corinne. Okay, so it tells you already the file that you download what it is. And here you have the different classes for the Corinne land cover and the areas per year. So in 1990, what was the areas of the different type land cover? So if we look only on settlements, in 1990, let's say that these are all the settlements where it says artificial surfaces. And the sum of that is 9,760 hectares. If I go to, so it's 9,760, sorry. If I go to 2018 and I sum also the artificial surfaces, it says 10,894. So the artificial surfaces in this province, according to land cover of Corinne, it has gone up by 1,000 hectares. Let's say if you are interested on looking at urban expansion. Okay. So you can use this data and do whatever you want to do with the CSV, with the Excel, make a nice graph, do anything that's more advanced than just maybe like what we have here. Finally, for the land cover, we have this very interesting thing, which is the change matrix. Okay, so you can click on the change matrix and it's going to tell you pixel by pixel what the pixel was. For instance, here you can choose your start and end point. So I want to see how the change happened between 1990 and 2018. So for each pixel or for each point on the map, it will calculate what was there in 1990 and if it has changed or not in 2018 to something else, or if I remain on the same class. So here you can see, oh, well, it's again, it's so many classes, so it's a little bit difficult to look at. But it's all of the areas where there has been no change, while other areas there has been change. So something that was I don't know. Again, maybe it's just a lot of classes, so it's not so easy to look at. But here you can see it as a summary also. So what is the original, what is the final, what is the change between 1990 and 2018? Again, maybe this is not a great example because this land cover, the Korean land cover is encompasses so many classes. Right, so that is one example of what to do with Earth map. I don't know if there is any more questions here. Maybe not. No. The next example will be, for instance, this is using the land cover. If we want to use the climate analysis, so we have in climate, we have, let me go back to the map, so it's a little bit easier to see. All right. So we have removed, there is nothing loaded now. You have in climate, we have data on layers on temperature and precipitation. I must admit that these layers are a little bit out of date because they have been updated for the last year or 2 years even. So they are not amazing right now, but they will be updated soon. But here, for instance, what you can see is the changes on the precipitation. So according to the chirps imagery, what is the change between what is the trend of the change on the precipitation in Serbia? So if I click there on chirps, I can see that according to this trend between 1981 to 2019, there are areas in Serbia that are getting more precipitation. Anyway, according to this product that is called chirps, which is a global precipitation data set, all right? And it has pixels that are 5 kilometers, if I can remember right. Yeah, the pixel size is 5 by 5 kilometers, okay? And the data is a mix of of remote sense data together with the station data, all right? So of course, this is a model. Again, we don't have precipitation data for every country from every region in the area. This is an approximation using the model that aggregates the data from remote sensing and from other sources with also data from actual climatology stations. Okay, so here, according to this, the precipitation in the center and south, or well, anyway, the west has been lower, while some other regions the precipitation has increased. So if I click on this province, let's do a test. So if I click here on Sumadisky, okay, so this is Sumadisky, I can now try to see according to the precipitation products what has happened in Sumadisky. So if I go to chirps here, I put chirps, you can just put precipitation chirps. And I can make an analysis. The first thing is here, if I click process, it's going to tell me invalid selection because I need to select here an option. An option should be the annual, monthly, or monthly averages. So I want to aggregate the data into annual data. So I want to see the annual precipitation. And I can click 81 to 2022. So you click there. Now, again, you are going to make the full analysis of all the data from 81 to 2022. Okay. Oops, the trend is missing. There should be a trend line here. But anyway, precipitation is going to make it clear. You have like some year in 2014 where there was a lot of rain, another year in 2011 where there wasn't much rain, 2021, that's around 800. So more or less the average there is around 800, I guess. But sadly, there should be a trend line. I guess I have removed it. I should put it back because the trend line is a little bit easier to actually, it's a linear fit on the doesn't appear anywhere. Anyway, there should be a trend line, it's not there. So this is the data by year. So you see, for instance, the last couple of years were around 800, while you had a bit more the previous years. And again, some bad years, 2011, 2003, 2000, around 600 millimeters. So something like 25% less than the usual 800. Okay. The data, you can see it, as I said, on precipitation and all of these type of data sets that we have in EarthMap, where you have like a dense time series, for instance, on precipitation, temperature, and so on. You can see the information, or in DVI, for instance, vegetation. You can aggregate the data as annual or as monthly time series. Again, this is all done on the fly by Google Earth Engine. So it's looking through all of the imagery from chirps, reducing the images to only your region and aggregating the data by months. So it's kind of a lot of work. It's something that you have to do yourselves in your R or whatever you're using for doing the analysis. It will take a while to do. So this is making the work a little bit faster. Again, as I said, this is done on the fly, so sometimes it takes a little while because also this is a lot of months. This is from 1981 to 2022. So let's give it some time for it to finish. And this is going to show you the precipitation month by month, right? Again, now we have a lot of data, so it's not super easy to see. Let's make it bigger. Okay. All right. Maybe you can see this a little bit better here. So we have from January 81 to October 22. So the last month where we have data from CHIRPS is October 22. So here in the graph, you will have information about the actual precipitation for that month according to CHIRPS. So if I go to May 2014, you had a lot of rain. Yeah, if I remember correctly, there was some flooding maybe in 2014. I think I have some example of a flooding in 2014 in a mine. We can do it later. Anyway, May 2014, we have a precipitation of 203 millimeters. I don't know, you can see this very well on your Zoom. And then in blue, it says 117. The blue, or like that blue bar, is the deviation from the average. It means that in that month, it rained 117 millimeters more as an average for the region than the average of all the Mays on the time series. For all the Mays from 1981 to 2022, the average was around then 80 or 90 millimeters. So that month of May, the amount of rain that you had on that region was more than twice the average of May. So in blue, you have when the deviation is positive, so you had more rain. And in yellow, here, you have, for instance, in this other month of November, the rain was 53 millimeters, November 2015, which means that this 12 millimeters of rain less than the average. Okay, so this is the meaning. The green is the actual precipitation, blue is the deviation from the average, so positive, and yellow is the negative deviation from the average. You can also use this here. It's interesting. You want to read this a little bit easier. So if I just want to read the last year, maybe this is a little bit easier, no? If I want to go from, okay, this is June. This is always the same data than before. So the data is the same that you were seeing before. It's just that it's a little bit easier to look at. Okay, so for instance, August and September 2022, according to this, were okay in the precipitation. You had higher precipitations than average, a little bit higher, while in October you had a lot less. So you should have had, but maybe actually one thing is, I don't know if the full month of October is considered here. It might be that October is not yet completely, the data set for October is not completely ingested in Earth Map. Sorry, in Google Earth Engine. So that's, maybe we shouldn't consider the last month. All right. Anyway, you get the idea, I think. If there's any questions here, wait a second, let me see. There's any questions? Am I boring you with this? I hope not. I think this is actually an interesting way to access climate data. But anyway, I guess when you do yourself, you think it's more interesting. But anyway, here again, you see the full time series, lots and lots of months, right? Again, this is difficult to look at or difficult to analyze, or really it doesn't really make a lot of sense. Maybe the easiest thing again is to export the data. Again, you can export the image, which will not do very good because it's actually not very easy to see the image. You can export the CSV. And again, you have here the file, Sumaditsky precipitation. Let's open it in Sumaditsky precipitation CHIRPS. So it tells you the province, the product, which is precipitation CHIRPS, and the aggregation, which is monthly time series. Okay, let's open it with Excel so it doesn't block. All right. And now, wow, you have lots and lots of stuff here. So this is really a lot of data. But you have for each month from January 81 to October 22, you have the actual precipitation and the deviation. And again, you also have here the yearly sum, which anyway, this is like for each, this we should remove because it's a repetition. But for each year, how much it rained, right? Anyway, you get the story. This will allow you to do an analysis later for well, anything to do with precipitation, I guess. Right. The last type of aggregation that we have is called the monthly averages. So if you click on monthly averages, and let's say I'm going to reduce this so it's a bit faster. So here you can choose your years, the years of interest. Of course, if you have a large area and you are only interested in a few years, then you should change the years because it will be faster. The more years you choose, the slower it will go. So if I only want to check the last from 2011, 2021, oops, 2011, 2021, click on done. So now I say I want to see the precipitation, the precipitation monthly averages for this period. I click process, and now this is going to give you basically the same information that before, but aggregated by month. So in this period, the average precipitation in January is 57, and the average precipitation in May is 102. So basically the most rainy month is May, and the least rainy month is November. So maybe do not go on vacation in May. This is actually very interesting for vacation planning. All right. We have again temperature. You can do the same thing. The only problem with temperature is this also needs to be changed because right now it's stuck to 2019. So let me do the average better. So for instance, this is the map of the average temperature for the average of the last 3 years, where this was data for ECMWF. This data set in particular has been updated now to a different data set that is a little bit more accurate, and it also has smaller pixels, and it also goes all the way to 2022. So I need to upgrade it. But anyway, this is the average maximum temperature per province or per region, or let's just load survey here. Okay. The average, you have the the maximum average, you have the mean average. So this is the mean temperature, okay, and this is the minimum average. So it's for the full 3 years, what is the average mean temperature? So you can see obviously that this is the coldest area in your country, no? While in this other northern region, it's more mild weather. Another thing in climate that is very interesting, for instance, will be the days. Sorry, specifically for you that work with irrigation, will be the days above or below certain temperature, because we also have access to daily data. What we showed you before was monthly data. There is the ECMWF daily temperature and precipitation data. So for instance, if I want to see how often do you have like I don't know, some proper rain in Serbia. So we have this product that is called the days with precipitation above a threshold. Oops, okay, don't look at it. Huh. Something wrong with it. But oops. You know, I uploaded a new version of Earth Map on Friday, so maybe that was the problem. Why is it black? All right, this won't work. So there's some problem with the precipitation. I'll look into it in a second. Instead of precipitation, if I want to look at again. I don't think you have more than 100 days or 32 degrees. Okay, so all right, I will I will fix this later. But I can still show you the statistics now. If I can show you not the map, but I'll show you the statistics now. For instance, for this province, we have these statistics on the number of days per year where you are above a certain temperature. So if I go here to temperature, sorry, to climate, where is it? Climate, and we have these heat stress days. So if I want to know how many days between 2000 and 2022, the temperature went above, I don't know, I guess 35 degrees. Let's see, you had any days where, according to this product, there was the temperatures above this temperature in this province, Sumadiski. So this for sure takes way longer because now we are not looking at monthly data, we are looking at daily data. We are going day by day, checking what is the maximum temperature for the day for every pixel within the province. And okay, let it run for a second. I'm a bit bummed that that is not showing the map correctly because actually there are quite cool maps, the daily maps. But yeah, this is the monthly averages, right? So if I just want to do the monthly time series, let's just do the last 5 years, so it's a faster process. So anyway, yeah, as expected, you have, it's not that many, it's only like an average for the area is less than 2 days in August and less than 2 days in July. But of course, this is considering the average of the area, counting the pixels that you have in the area. You see, you have multiple pixels per within your province. So it seems a bit counterintuitive because days here are counted as a real number, 0.28, 1.44. But that's actually giving you the average of the number of days above that temperature for every single pixel within your province. Okay, that's why you have a real number. For instance, here we look at the last years. Let's make it bigger. In this province of Sumadiski, I'm sorry, I'm pronouncing it terribly. Sorry for that. You have a year in 2017 that was pretty hot, where you have an average of almost 5.5 days with temperatures above 35 degrees. Then June 2018, 2019, and 2020 there were almost no days above 35 degrees. And then in 2021, you had a little bit of days about 35 degrees. And on this year, only 1 day. I don't know. I hear Rome was very hot this year. I hope it was better in Serbia. Okay. I feel that maybe we can right now take a 5-minute break, and okay, and then we go through a little bit of other products that we have, right, in EarthMap, and then some practical examples. But if you guys are okay, I will do I think it was also in our plan to have a a little break. So
Yes.
yes,
Yes, Alfonso, we can have a break.
yeah, and then we move into the other types of products that we have. I don't know, maybe I'm going a little bit too deep right now, or it's okay.
I don't know.
It's
Let's
okay.
see what. Okay, perfect. Okay, so how much you said, Alfonso? You're the boss here. 15 minutes break.
Yeah, let's do 10:30. So it's 10:15 now.
So colleagues, please, let's make sure that we all regather at 10:30, okay? Thank you very much all. We will just be back in 10, 15 minutes. Over.
All right.
Okay.
A ver, so I think we can resume.
Thank you, Alfonso. Are we all ready to start? Are we all here? Seems so. So Alfonso, please. Let's get started, and then anyhow we do have the recording. Please go ahead. Thank you.
All right. So again, please do interrupt me because it's very difficult to do this sort of presentations or trainings where we don't have a physical presence. Because I don't know if what I'm telling you, you know about this already. Maybe you don't, or it's too simple, or you want to do something more advanced. I don't know. But also exactly what are your goals as well with your analysis. So anyway, this is something we will discuss later in any case, because we should see what could be the practical uses of earth map for your projects. But in any case, if you do have questions, please do interrupt me. So we have seen that we have the land cover data sets. We have the climate data sets, even though the heat stress and that wasn't working. But anyway, there is even something interesting. I haven't even checked in Serbia if there is any change on the aridity, because there is some aridity calculations just using the precipitation and potential evapotranspiration, where you can see the increase or decrease in aridity. So according to some of these calculations, the aridity is increasing in Serbia, but as you see, it's not a fair product. But maybe we can just look at the median aridity. So according to this, some of your areas in the north, in the more productive area, there is some aridity. They're classified as semi-arid according to this. Oh, interesting. Anyway, we have the aridity data. We also have information that could be also interesting on fires. I don't know if you're using at all doing any kind of analysis on fires on agriculture, or crop residue burning. I don't know, for instance, here we see that according to this map in 2022, you have this area in the province of Yuzhno-Banatski, where there have been recorded some big fires, but I don't know if it could be crop residue fires or just like a fire. One interesting thing, okay, let's see what was behind this. Again, you remember you have these, oops, sorry, it's too much. My computer is really not working super well lately.
Excuse me, may I ask something?
Yep.
About these data providers and data, where we can find the information who provided the certain data?
So yeah, so you have the information window here. During the information, you get the source. So for instance, the burn area is produced by the USGS. Was it NASA or USGS? No, yeah. This is a product that is used, right? And you can also get some more information. All right, we need to update that, by the way. And the data source that takes you to the USGS. Oops. So this is a USGS product. So yeah, when you get the
Okay, I understand.
Yeah.
Thank you.
okay, let me write that. That is a new version. New version. All right. So for instance, if I wanted to understand if this is something like that happens every year, or let's say it's just I don't know, some problem on 2022, you can change the year. So I can go to 2021. I can click on, and I can see like in 2021 there was no fires recorded there. There was another one here, but not there. So it must be just something that happened every year, and that's not. It's not like they burn every year the same areas. Although maybe there is some kind of relationship there. So again, with the fire, of course, you have the fire by land use. So you mix information on the fire with the land use that is supposed to be under on these areas. The most interesting part will be, of course, to find fires in forest rather than agriculture. No, for the loss of forest. Let's go back here. If we can see any fire. So for instance, here, let's go back to 2022. No. So according to this, in 2022, there was some fire. Oops. Okay, some small fires here. I don't even know. Maybe this is not really right. No. Oops. 2019, 2020. No, well, you don't really have much of a forest fire problem in Serbia, it seems. Fire seems to be more around the agriculture provinces than anything else. There is also the fire frequency. Maybe you can see some hotspots of fires. So this is basically taking the information on fires, doing some kind of analysis in which for each pixel you count the number of times that pixel has been counted as there has been a fire for a year. So you see around this area is where you have more common fires in agriculture. Again, if I wanted to now make this analysis, why specifically in this area there is some more presence of fires, maybe instead of using the full province, I'm just going to draw a polygon. So I can just click here, right? And then you see there is a plus button. You can click on the plus button. You can draw a new boundary. And I'm just going to draw a boundary like a triangle here. Okay. And now when you close the boundary, you can put a name, fires, agriculture. Okay, I click OK. And again, I could go here, click, and open the statistics. And now there is the barn area product. So you can go to barn area. So for instance, I can get the monthly time series. So you can see for this area, again, it's not super easy to see. So maybe you can make it bigger. So you had in October, in 2012, in September and October, there was a lot of fire, especially in October, 11,000 hectares. Other than that, it seems that usually around September, October, September is when you have your fire. So it actually may be related somehow to some burning of crop residues. Well, although the last years, 2020 to 2022, it seems that that there has not been that many fires in that area. Okay. Again, there is also like aggregation or like a mix of the barn area with the land cover, so you can see what that land cover corresponds to. So you see that according to this, all of the barn areas in this region are all in cropland, so cropland fires, especially 2012. Okay, but you have mostly just 16,000 of cropland fires. Okay, with again with all of the graphics, sorry, all the statistics, you can download the files. All right. Other type of analysis we can do is in vegetation. So if for that same area, I want to see the vegetation average, right? So anyway, this is all of a agriculture area, agricultural zone. So you can see the average NDVI for these years, 2020, 2019. Again, this has to be upgraded or updated. You can see the areas where you have maybe more forest, right? And the areas where you have more, I don't know what this is. No, will this be? Maybe this is a mine or something like that. Yeah, this is a mine, no? Yes, so you have a mine there. So of course the NDVI here, the NDVI goes from brown to green, no, to signify the vegetation intensity. The NDVI, if well, I guess you all know, but if you don't know, it's a way to measure the intensity of the vegetation using the infrared bands of the sensors in the satellite. So this is a NDVI product derived from something called MODIS that has a resolution of 250 meters. Okay, maybe it's something to look into later, because there are for NDVI or for remote sensing imagery. Of course, you are depending on the satellites. Each satellite has a different type of sensors. So, for instance, MODIS, which is the one that we are using now for this visualization, has data from 2000 to present, and is daily coverage. So every day there is an image from MODIS. It has a resolution of 250 meters. We have other satellites that also offer this kind of imagery, but of course they have a different temporal resolution. So for instance, we have the Landsat, which is 16 days temporal resolution. So you will have an image, basically an image of Landsat every 16 days, and the Sentinel-2. Maybe later we are going to look, well, maybe later, no, later we're going to look into something called imagery compare, where the imagery compare uses directly the single images from Sentinel and Landsat and MODIS, and maybe you will be able to see better the difference. Here, what we have showing here is a composite of many images for a series of years, while in the imagery compare, you see a specific single images, so you can see the difference between one day and the next day. In any case, here with the NDVI imagery, you can see the presence of vegetation. And in the cropland and grassland, you will find this kind of greens. Grassland will go more, or rain-fed cropland will be more in the orange or red, while the absence of vegetation, you see here the peaks of these mountains, these mountain areas, they're all, or the areas where there is cities, then you have brown kind of color, okay? Or is the, let's say we were saying here, the mine also, there is a lack of vegetation, so you have brown colors. But the vegetation is interesting. Let me go back to the presentation, okay? So we can go into some specific examples, right? Anyway, we haven't really gone through all of the themes, but there's lots of them, so I think we can explore them later. If I go to the presentation, then maybe we can see a specific example of how to use the vegetation index. So if I go to this area on Sapano Baki. Oh, no, don't. Okay, no. So if I go to this specific area on Sapano Baki, this is, oh, wait a second, maybe I have it here. Yes. Okay, so if I click on this, right. Let me do that. I can now, this is a pivot irrigation on this area of Serbia. All right. So as you can see from the images, you have these 4 fields that are using this pivot irrigation. I can click on this, and now I'm going to run some statistics, right? I could, first of all, before even I look at the statistics, I can look at different maps from satellite imagery. So what we see here is the Google Maps image, and we only see one image. I don't know exactly what year this image is. So we see this image from Google Maps. We have access here to the Landsat imagery. And Landsat imagery, we can see images of the plot in different years. So I could see in 2020, right? There is no signal of that pivot irrigation, or in 2029 and 2019. See, there is no signal. In this specific product is available only until 2020. Sometimes it gets stuck. You need to zoom in. Go. Okay, now it finishes. Okay, so you see that according to this imagery from Landsat, we don't really see. Okay, sorry. This is called the greenest pixel yearly. So these maps are a mosaic of all of the imageries from Landsat. Landsat is this NASA satellite where you get one image every 16 days, and we have access to it through Google Earth Engine. So what the greenest pixel map does is to put together all of those images and find the image throughout the year where there is more vegetation. Okay, so it's the pixel in throughout the year where the vegetation is stronger. Of course, one has to be aware that these are optical sensors on Landsat, means that if there is clouds, if there is cloud cover, the image from the satellite is going to be covered by the cloud. So you are going to see clouds, right? So it's not that every 16 days necessarily you have data from the ground, because if you're unlucky, it might be that Landsat has taken images, I don't know, for 3 months in a row, in which every 16 days there was cloud cover. It depends on your area. This is a big problem. For instance, in the tropics, there is lots of cloud cover. It might be that it takes months before you get a proper imagery from the ground. In any case, these specific images take the Landsat imagery and and get the available images without cloud cover, the best possible, or the pixels with the highest vegetation. Anyway, so I see that 2016 there is no pivot irrigation. So what I can do is now use to understand where this pivot irrigation started. I could go into the vegetation index. I could use the vegetation index to understand how this crop changed throughout the years. So if I go to vegetation here, you notice that we have three options. We have the MODIS option, the Landsat option, and the Sentinel options. And you see that there are different resolutions. The Sentinel-2 is the highest resolution, while the MODIS is the lowest resolution, right? 250 meters means that the pixel is very large. While in Sentinel-2, the pixels are much smaller. You can actually see much better the area. So if I go, since I know, or it seems that in 2016, this was still not pivot irrigation, I could choose. Okay, just a little explanation also. So in the Landsat and MODIS, we have imagery from 2000, while Sentinel-2, we have only imagery from 2015, okay? Because it's a newer product. But since it has a higher resolution, it's actually better to use that one because you have information that is more specific to your area of interest. So if I do now the monthly time series of the last 5 years, I can keep process. And I will be able to see the changes on the vegetation for this region, sorry, for this plot in this area, but it's not super clear because we see here that there is some changes on the vegetation indexes around January, February 2021, but that might be also related to snow. But I don't know. Is there snow that area? So it's not like super clear here. When did the pivot irrigation appear? So what we can do instead of using this NDVI, anyway, you can see also that the NDVI actually didn't really change much. I'm a little bit confused now. What happened here? So the NDVI actually went down in 2022. Okay, see. So definitely something happened in 2021. Let me check. So we have an option when we want to look into specific images rather than yearly imagery. That is when you are looking at something on Earth map or clicking on an area of interest in Earth map, you can go here to open AO area of interest with, and we had the imagery comparison tool. All right, and this tool allows you to look at the specific dates, and specific images in those dates. And this is actually something that you can use all the way until 2 days ago. So because you have in Google Earth Engine, basically there is a 2 or 3 days lag between the images and when they're available. So for instance, here we can see an image, right? Well, we have a way to compare imagery. And this is an image from Sentinel-2 in both sides. What you see here is a false color mosaic. Maybe I'm putting too many things here. But anyway, this is a false color mosaic, which means that we are using the near infrared, short wave infrared, and red bands. Usually when you look at something, when your eyes, you use the 3 bands of red, green, and blue. no? And the combination of the red, green, and blue gives you all the colors. While in the satellites, their sensors they have, their cameras, they are able to capture other wavelengths. So not the red, green, and blue wavelengths, but the near infrared, for instance, in this case, several bands of shortwave infrareds and near infrared bands, which we cannot see, right? But they are a good indication for the chlorophyll content and for the vegetation intensity. With Google Earth Engine, we are able to combine these different bands in order to bring up the vegetation on the ground. But what you see is not the normal, how you will normally see vegetation. In this case, vegetation is actually shown as red. With this band combination, what you see as red is vegetation. In this case, for instance, these strong red colors means strong vegetation. So this is some area where right now, by the time of this image, if I click on the image, it will tell me this is an image from the 16th of October, from last month. All right. So in this area of Serbia, they have some crops here that on the 16th of October are in full swing here. Okay, I don't know what type of crops they might be. While on the plot, or sorry, in the plot, on the area of interest where I have drawn my area of interest, there is no vegetation or very little vegetation because this is a very pale green. So vegetation is shown as red. The strongest the red, the more vegetation. Or for instance, these oranges means that there is some vegetation, but not so much. For instance, in this specific field, you will even be able to see that for this field, you have some areas of that field that maybe they have a different soil or they have a different, I don't know, water access. I don't know. There's some differences in the specific soil, where you see that there is areas of the field that have much healthier vegetation than other areas. This area in the middle here means that there is some problem on that field or some issue, or I don't know. There is less vegetation in any case, right? So again, green means no vegetation, red, orange means vegetation, and then depending on the different colors, you have different type of vegetation. For instance, this red here might look actually like what is this? I don't know, I thought it might be trees, but it's not trees. The trees are here, but I don't know what type of crop is that. Anyway, you see the situation on 2nd of October and the situation on that same area from last year on the 20th of November. You can change the year. So if I want to check, let's check. Just a second, because maybe this is the problem is that $1,000. Because in yeah. Okay. Huh. We should be able to see the pivot irrigation, but let me check if I can just change the year and see something. So if I go back to 2020, that should be like in May, I guess. Let's see if we find an image. So basically, you can use the calendar to look for specific images throughout the years. This is what I say, for instance, this is an image from May that you see everything pink, and it's because there's clouds, no? So the clouds make it look pink. So it's a really heavy cloud cover. You can't really see anything that's all just pink. That also might happen with the snow. If you find places that look pink, might also actually be snow. So you can go throughout the year and trying to find images. Of course, the clouds will be a problem when you look into like single images because there is no cloud cleaning. So again, more clouds. Anyway, here you can see in this image, there is some sort of pivot irrigation, like there is some leftover from pivot irrigation there. You can see the little circles. Anyway, I did this a couple of weeks ago. I cannot remember exactly what it was that I wanted to show here, but you get the idea that with these kind of images, you can access is pretty great because you can access specific dates. So you are interested on something that has happened on a specific time, then you can access this type of imagery. When you click on the image, you get the date, the specific date of this image that you're looking. So this is from 8th of June, 2020. Okay. You can also download the images. Okay. So you could download this image. Again, if you want to put it somewhere. So you could download it again as PNG or GeoTIFF. So you needed this image for putting somewhere. You can also download as PNG. You can also put GeoTIFF and change the bank combinations or do all this kind of work. Okay. Again, for GeoTIFF, you need to have QGIS or ArcGIS, something like that. You could also, for instance, this is already drawn. But if I want to measure something, for instance, reset map. If I wanted to, I don't know, I want to measure this field for some reason, right? Because this field, I want to do something with it. So you can just measure the area here. You click, see, up here on the right, top right, you click measure area. This could be, for instance, handy for people using more than anything for the fires, but anyway, you could say, okay, I have my field. I put it like this. Okay, and it tells you that this field is 108 hectares. There's a nice field. And you can also download it as KML. So you can this button to download this KML. And this KML, for instance, you can just open later on Google Earth. You have Google Earth installed or you have any other type of geospatial software, then you can always use your KML to load it there. For instance, if I want to access very high resolution imagery in Google Earth, you have access to very high resolution imagery that could be useful. So you can go year by year also on the. That number is different from 2020 to what we see in the image. Strange. Anyway, this is something very interesting for you guys, which is the possibility in Google Earth. The possibility in Google Earth to access very high resolution imagery as well, because what we are showing in Earth Map is the imagery from Landsat, Sentinel, and so on, which is an okay resolution, but it's not submit the resolution like this. No, here you can see way better, and you have also access to quite a few, especially in Serbia. You will have a good archive, so you can change. This is 2013 October. This is 2006. Okay, there is maybe some kind of issues with the positioning. You know, it's not perfect, but. Anyway, this is also for you to be aware that this is a product that you have in Google Earth. So in the normal Google Earth, not in Earth Map or in Google Earth Online or anything like in the Google Earth that you have at home or you have in your computers installed, you can always activate this historical imagery function, okay? Which is very handy and you can move through the years. This could be very interesting for your project, I guess. Right. We'll go back into the imagery compare later, or actually now, because the next example was for here. So wait a second. I actually did have a link about this. Is it working? See. Or maybe not. Sorry, it's not working. Anyway, enough with the pivot irrigation stuff. Because I actually did find, I guess, the images from 2016 to 2022. Yeah, in September 2022, you could see very well but why in September? Wait a second, because you cannot really see it in October. What happened here? So you had to actually find the image through the. This was what? 6th of September. Let's see. Okay. So yeah, this is the image from the 6th of September. Well. Anyway, you see, for instance, here the clouds and the cloud shades, the shadows of the clouds, right? So you have to count always when you see this kind of image, black pixels. These actually are cloud shades. Although it could also be water. Water is also black. If we see like a lake or something, you will be able to see it with a black water here. Yeah. So you see here the riparian vegetation, no? So these probably are tree plantations, no? And the black water, and it's even the sand. You can see some sand here, some white sand. So there you have like some kind of beach there on the Danube, or like an island or something. Anyway, are there any questions about this? Anything?
Colleagues, feel free to exploit as much as possible Alfonso. He's at our full disposal, so don't be shy in asking questions or posting them on the chat. Thank you.
No. Or I don't see anything. Anyway. Yeah. Anyway, they are beautiful images in any case. For instance, let's go back to the next example. Yes, this is something I think you might find funny. So this is something I found a few weeks ago as well on Serbia, which is the NBA player that is called Darko Milicic, that apparently came back to Serbia to start apple farm. Okay, so this irrigated apple orchard, okay, from this guy Darko, which actually like seems that he didn't pay his workers for a while. That's in the news. First of all, we have the okay, let's just remove this. First of all, we have here the Korean land cover for 2018, which is giving us some information about the area. So you have the different types of agriculture. You have here that there is some permanent agriculture. We can see here the color. permanent crops. Anyway, you can see also, remember that you have this pixel inspector, so you can click and then it tells you exactly on that pixel what is the legend, sorry, what is the classification. So you see that this area has been classified as arable land, non-irrigated until 2012, and in 2018, it has been classified as permanent crops, fruit, trees, and berries. Okay, so we know it's here in this land cover map, you can see that there is they actually found the change on the land cover. If I close this, then I can see the very high resolution imagery. You see very well that you have this nice field with a lot of trees, sorry, of apples, and they build an irrigation pond, a big one. No? So if I wanted to know when this irrigation pond has been built, oops, sorry. I could use, for instance, I could use several things. For instance, one thing I could do is to use the vegetation index. So vegetation is, well, the presence of water is very simple to see when you use the vegetation index, because the water has a 0 vegetation index, right? So if there were crops there before, you will see that the vegetation index it goes up and down through the year, but it's more or less high, let's say. While if there is water, the vegetation index should go down a lot, because the water should be 0. The vegetation index of water should be 0. Maybe it can fluctuate a bit because maybe there are algae, or maybe like not the full pond is filled all through the year and so on. So it may be not 0, completely 0, but it should be quite low. So if I use this concept then, and I know there was a change in 2018, I could, for instance, use I can try with Landsat, with the vegetation index from Landsat from 2000 to 2022 to see how it changes. Maybe to make it a bit faster, let's do 2010 to 2022. And let's put here a monthly time series. Process. Now it's going to go through every month, doing the Landsat, blah, blah, blah. And here you can see very clearly how, for instance, in this pond, before, well, it was built on 2015, because you see how the vegetation index changes, no? So I mean, it's not specifically 0, because perhaps there are some pixels. If we look at the Landsat images, here, you see the pixels are actually bigger than the pond. No, there are some pixels. These are 30 by 30 meter pixels, so they actually come out of the pond. So they actually capture some of the vegetation around the pond. Okay, so this is an interesting way of using this, and we see this is 2017, no, that they built it. So we can even, using the Landsat greenest pixel, we could go to 2017 and see how it was in 2017. And we see that in 2017, they had already started with the pond. You had the pond there. You already even see like the squares here, and also they started also the planting of the apples. While in 2016, they were already starting with some of the apple tree plantation, while here there was something else that was not apples. I guess whatever it was there before, some other type of agriculture. And if I go down to 2015, again, they already had started doing something there. 2014. Yeah, and in 2014, there is absolutely nothing related to these apples. Again, you could also even Let me see if I already have it here. Yeah, so you can do like you imagery compare to look at the difference between 2014 and now. So let me just click. This is going to show us the images, single images, not like this. What we are showing again, what we see here on this greenness pixel yearly is like a processing of many images to make a yearly image. While this is the actual image from before and after. So you see here now the image from August. So if we wanted to, we could even go to right now. So let's go to November. Let's see if we are lucky and there's an image from without clouds from this week. You have to be a bit patient because sometimes there is no images, sometimes no. Look, so the 9th, this is all white. So this means again, this is clouds. So again, you have to be lucky to find the right image. More clouds. So I guess now November is not a great time to find images. Clouds. Now, okay, so this is the image from, let's click. If I click on the thing, on the image, you see that this is the image from the 26th of October, right? So it's not too long ago, it's two weeks and a half. You see also that there is no water on the pond, all right? Because if there was water on the pond, you would see this black. And instead, what you are seeing is this dark green. So it means that the water is not there, or maybe it's just wet, or there's very small, like a very small depth of the water, right? If it was water, if it was really filled with water, the pond, it would be totally black. So you will see it perfectly well. And if, I don't know, maybe you don't see this well in Zoom, but in my screen, you see clearly that it's actually, it's dark, but it's not black, it's black, it's dark green, right? But you see the orchards around. Okay, so this is the image from Sentinel. Here, you can choose the different, you can choose the different suppliers of the imagery. If you are going to use images from 2017 onwards, then I would recommend you to use Sentinel, all right? Because it has this nicest resolution, it's 10-meter resolution, all right? If you need images from 2000 to 2017, then you should use Landsat, because Landsat has, I'm sorry, it's getting very cold here. Landsat has images from 2000, but you see the difference. This is Sentinel on the right, all right, from October 2022, and this is Landsat. You see the difference on the pixel resolution. This is from 2014. So the pixel on Landsat is much bigger than the pixel of, or the resolution of the imagery is much better for Sentinel than for Landsat. But anyway, in Landsat, you are able to see that this is just an arable land, it's a field, an agriculture field, but it's not what it is now. It's not this orchard that you have now. So this is also an example on how to use both the results from the Earth map, where you can see the changes, no? That from 2014 is where you have the change. So here you can, for instance, see when this pond has been built. Here you can actually look at the specific images. And I can see, for instance, that in October 2022, you see the NDVI of the plot is 0.2022, which means that it's not filled with water. If it was filled with water, the NDVI should be lower. It's just like there is not much vegetation. It's just, I guess also it's probably a pond with covered with some plastic thing, no, like for the infiltration. So Anyway, this is an example. I thought it was funny because it was an NBA player that had this orchard thing. Right. One thing is interesting. If, for instance, you find anything like this and you say, oh, well, this is interesting, you know, maybe I want to put this other, I don't know, band combination. You can change band combinations to make it look different. For instance, here you see that using different band combination, instead of the near infrared, short wave infrared and red, we use near infrared, red and green. The color changes. I mean, more or less is the same. You have black for water or for low vegetation, you have darker colors. For stronger vegetation, you have stronger red colors. So it really depends a little bit of how you prefer to look at the imagery. Some people prefer it one way or the other. Okay. But if you wanted to share this with someone and you say, look, I found these very interesting projects here in this area, you could, for instance, I click on this measure area to say, okay, I have this field and you want to measure and you say, this is whatever, 62 hectares, blah, blah, blah. And look at what happened between 2014 and 2022. Here in this case, if you want to share this link, you can click here, share link. Okay. And then you need to click here. So you click on share link, then you click here, and then you can share this, right? So you could use this link that is generated, and this link that is generated, then you can just open it anywhere, and it's going to show you the same stuff. So you can actually share with people these imagery compare URLs as well. I mean, I hope it works. So I don't get another demo issue. Extreme. Look, great, doesn't work. Perfect. It doesn't work. All right. Great. Probably it's because of this reset map. Okay, so it's a problem with the polygon. Yeah, you know, it's great when you do the showcases of your tools, because sometimes you don't really test some things, but now you are forced to test it where you where you show it. All right, so that was another example. So another example I found in Serbia, but do ask if you have any questions or whatever. Another example that I have for Serbia, which is maybe also somehow related to irrigation, maybe, or precipitations, is, for instance, this example of the Kolubara coal mine, which was a really big, it's a huge mine that you have there in Serbia. It got flooded, and that caused a lot of costs for the state or for the electrical company of the state. So, for instance, this Kolubara coal mine, this is the state that it was according to Landsat. This is Landsat imagery. So this is the image from April 22, 2014, 22 April 2014. This is the image also from Landsat, okay? Because in 2014, we don't have Sentinel images, but you have Landsat from August 2014. And you see that there is before it's all green here. Green means that there is no vegetation. Of course, a mine, so there is no vegetation in the mine. There's some clouds and so on. You have all the crops around. So you have the areas that have red, which you have the vegetation, the other fields that are fallow, that there is no actual crops there. And you see afterwards in August, how this full mine, all of the mine has been flooded. Okay. So we could do a test, for instance. We can see what is the precipitation, what is the, again, we can do the same thing with the NDPI. You could measure the area here. So let's see, like this area that has been flooded here. Okay. I could download it as a KML. And now just to show you how to use that in EarthMap. So you had a KML file, for instance. I could go now in EarthMap and click on the plus button. And I could upload that. So I'm going to upload the KML file here. All right, so now I have this KML file. Maybe you don't see very well. Oops. Let's put here the map so you can see this. Right, so you have this KML file that has now the area, the region. I can click on it. And now again, I can do the time series. So I can click on process. I see NDVI. And at the same time, we are going to look at the precipitation data, no? Precipitation. So I guess that was what we saw before as well, that in 2014, there was a huge spike in precipitation. So we do maybe not 2000, maybe 2005 to 2022, on series. All right, so here is very clear that if you look at the mine was covered by water for a long period between so here you see the vegetation index is not very high, 0.3, but it's still above 0, no? So between this period, I cannot really put the date properly, but so between, anyway, March, June 2014 to around June 2015 for a full year, that for a full year, this plot or this polygon was covered by water. Okay, and again, we can see here. You look at the precipitation. Let's see if we can see this properly. That, yeah, on the months of May and July, specifically May, but also July 2014, there were huge, or there was a lot of rain, a lot more rain than the normal. No, I mean more than twice the amount of rain that you have in a normal month of May or July. Okay, so we have all that data. Specifically, I mean, I understand you are working with irrigation. So we can look at the hydrology maps that we have. So the hydrology maps that we have contain, well, we have curve number maps. So like the indication of the well, for instance, we can read the definition for each one of these. So it's this is our own model where we combine the land cover, the content of clay in the first meter on the ground and the slope to generate a curve number to get the measure of the permeability of the soil. Okay. So we can do that one. All right, it's quite the same kind of everywhere. Of course, in the areas with urban land cover, then the curve number is very high. We have, I don't know, soil information on the type of soil type, you know, the USGS soil type. So the hydraulic soil group soil type. We do have, no, for instance, actually one that is very interesting also is in the soil. We have the soil texture and multiple depths. So this is also a global map of soil texture where you have the soil content and different depths. So you can choose here the band and you can see the soil content. Sorry, the type of soil according to this product. If we want to do maybe like a, if you want to maybe go into a region. So, let's do basin, maybe like a basin, no? If we just do a small basin, no, sorry, a small basin here. If I want to estimate, for instance, using the curve number and the, okay, for instance, I don't know, just a random place here. So we have this, okay, this small basin here next to the, well, here, you know where it is, Saba, right? And I want to, for instance, know what is the precipitation, also the average precipitation between the last 22 years. I want to do the monthly averages. So to know more or less when is the precipitation happening here. So again, yes, you have around, as an average, 96 millimeters in May, 91 in June. Okay. So we also have this runoff product here in hydrology. Okay, that estimates using the curve number, using the curve number and the precipitation data, estimates what is the total runoff in that basin. Okay, you can do this in any scale. So for instance, according to this, of course, the runoff on the per pixel depends on the slope, on the land cover, and on the curve number based on the land cover, and the precipitation for that year that comes from ECMWF land. Here you have, for instance, some information on that, or how this is calculated. So again, you always have the information, and even this, I think there is even a PDF. Where is it? No, here, data source. Yeah, so there is even a PDF that explains what is the process to generate this curve number, and what is the process to go back to the runoff. So anyway, this is the map for the runoff for 2021. Could go to 2020. Change, maybe I still need to update to 2022. Runoff. All right, so again, it's another map. If we want to calculate the total runoff for the basin, we can go here, the statistics, and do again runoff, and calculate, for instance, the total runoff. Let's do just a few years because otherwise it will take a while. So the last 10 years. Ooh. So according to this, the runoff is in millimeters per year. So you had a peak in 2014, of course, when we had this really important precipitations in May and July. And then for the rest of the years, you have around a runoff of around 124 millimeters per year. So for every year, the average runoff in the region is 125 millimeters per square meter. Okay, so this can give you an idea. Of course, when you use the smaller the basin, the better the idea for the irrigation planning. But it's a combination of the precipitation data with these other data and curve numbers that we have for estimating runoff. Again, also that is explained on the source where you can read more about how this is done, the process. I don't know, is there any specific interest or more information about some type of imagery or layers or analysis? Any questions? Anything that anyone, well, wait a second, is there anything on the chat? Never works. Okay, there is some raised hand maybe.
Yeah, it's me, Alfonso.
Ah, okay.
I have a question about how we can effectively use this tool. I mean, you showed us a large number of possibilities, options, files, and I know that tomorrow we will move more into concrete use of the tools. But I just wanted to know, assuming I know a precise area, can I upload a file and then concentrate my analysis around the area that I have uploaded? And if so, can you show us something?
Definitely. Before I show you, like when you have an area of interest, I mean, if it's a very clear case, then you could just draw it. So, okay, if let me just remove this. So I don't know, my area of interest is the small area here. This, let's say this is little forest. You could just draw the forest. Okay. This is very fast. Okay, so you could just draw, you could make it as complicated as you like. And then you just call it forest 1. And that will stay here on your boundaries. So next time you log in with your username, like for instance, I log in with my sanchez.paus@gmail.com address, you will keep it here. The other option is to upload the boundary. So you have a shapefile, for instance, you could upload a GeoJSON, a KML, or a shapefile. Maybe this is a GeoJSON. Okay, for instance, this is probably a shapefile. Open with. I know this is a lot of shapefiles. Right. So if you have shapefile. Sorry, just a second. Extract here. Everywhere. You should be able to upload a shapefile that has all the files included onto a zip file. Let me just very fast do it. So yeah, it's totally possible to do. Okay, so for instance, if I had this shapefile, the Kenya, this is, I guess, administrative boundaries or whatever, I would just have to put together all of the files that belong to that shapefile. Okay. And maybe compress that to archive, make it zip it into a zip file. Okay. Right. So I have that. And now here I can just choose that. Right. So I guess it's that one. Yeah. So you see now, you see here this shapefile, but this is just the country of Kenya. But you could upload it, and of course you could have a shapefile with multiple polygons or one single polygon or whatever type of shapefile you have. It's just, I mean, the only thing to consider is that you cannot just upload the .shp file. You need to select all of the files that go together on the shapefile and make a zip file. And then you can upload the zip file.
But I can also upload, sorry, a KML file, right?
Yeah, a KML or a GeoJSON as well.
Okay, a KML file is a file that originates from Google.
Yeah.
From Google Earth.
From Google Earth or even from Earth Map. Sorry, from Imagery Compare. So here in Imagery Compare, if you find something that you want to open in Earth Map or you want to draw attention or whatever, you could click on Measure Area, then build your polygon for your area. Okay, let's say that. And here it shows you the surface of that polygon, but you can also download it as KML. So once you have downloaded as KML, here I send my downloads. I could go back here now to where I was in Kenya now, but I can just come and say, okay, I want to upload the KML. Yeah, and I have my field there. So that's another option, or through Google Earth. If you think Google Earth, there is another, I don't know, something that you have in Google Earth and you want to do it through Google Earth. I don't know, building a polygon of interest. So for instance, here you could draw a test 3, let's call it test 3. Let's say that this is my pivot, irrigation, whatever. I mean, I'm not very good at drawing, obviously, but let's say that's that. Okay. And I save this as KML, as KMZ, no, as KML in the downloads. Okay. And again, I could upload it here. So always the same, you go to the plus button here. You have all of the boundaries that you have uploaded yourself. You could remove them or you could download it again as KML. Okay. I could just upload the test one test. It's going to look kind of weird, but there it is. My pivot, my not super great pivot irrigation. Yeah, it's not very good. Yeah, and again, you have them here. You could delete them or you could download them again. For instance, if you upload the shape file, you could download the KML. So now I can open that KML file in Google Earth. So I mean, you can go from shapefile to KML and so on. So for tomorrow, I think the best thing will be if the people in this training, because then we should go into something more specific about because I don't actually know exactly what you want to do or what you are doing. I know it's working with irrigation in Serbia, but that's kind of a lot.
Well, and then besides the training is not only for the purpose of irrigation, but the training is more generally for colleagues in Serbia to use these kind of tools that are also paramount in addressing irrigation, drainage, and all water related issues. I advise, unless Maria and colleagues are of a different opinion, that we concentrate on water resources, not necessarily on irrigation, or tomorrow morning, if colleagues have a specific irrigation area that they would like to look at, we can work directly on that. So I would leave it open on that, as far as we remain within the water management sector. Then, if you see it possible, it could also be good to look, for example, when you showed at the beginning of the training the watersheds and how these are mapped, and it would be good also to see how non-water, directly water-related resources, such as forest, for example, could also have an impact on water resources by simply looking at some random watershed. But I really leave the floor to colleagues that are receiving the trainings, because it's really for them then to use it more than for us. So Maria, colleagues, if you have specific requests to ask to Alfonso for tomorrow, please feel free to take the floor. Over.
I don't have any specific request, but maybe Gordana has, as she raised a hand.
Excellent. Please, Gordana.
No, I also don't have a specific question, but I have one more let's say technical question regarding this navigation tool. You know, on the left top corner, there is you can enter location, and when I type, for example, Belgrade, it doesn't navigate to Belgrade if I'm somewhere else. Can you check if it is also the case with you?
But it works. Maybe something related to your.
Okay, that means that only I have a problem with this. And also, I would like to ask this watersheds. There are several boundaries regarding watersheds, bathing level 6, 7, 8. Do we know what are the size of the basin? For example, for basin level 8 or 7, I don't know.
Yeah, I don't know. It's so it's an iterative process. They do with using the elevation model. So they start at continent level. So basically, you go to.
Yes, but what was the criteria to define this basin level 6 or 8? It should be the smallest area, or I don't know.
Yeah, I think just 12 is the one that they can process basically globally. So this is a global product. So you go to any country, you have these basins at these levels.
Yes, but usually we define these watersheds, let's say, bigger than 10 square kilometer or 100 on the 1,000 or what else. Do you know this criteria, or it's just like that? I don't know.
Yeah, no, they don't have a no, there is no criteria like that that I know of. I mean, they just go iteratively subdividing using digital elevation models at different scales.
Okay.
So, but there is the because we don't have a link to that, but there is the whole methodology for that is because this is not our, let's say, it's not our product. This is it's WWF that does it, and they have a whole website on what's their methodology. and maybe I put it on the chat if I can find it.
Okay.
So there you can. I'm sorry, but the thing is, I read it like 5 years ago, and I don't remember exactly right now how they did it, but basically I think they just went to the level they could manage processing wise on a global scale. I'm sure you could make even the smaller basins. Or you could provide us with your own boundaries in Serbia, and we can use those ones, you know.
Also, we can, I am not telling that we will do that, but theoretically speaking, we can also provide some data.
Yeah. Yeah. No, I mean, this is something we are doing with other FAO projects where we are making kind of, hello? No, this is something we are doing with other FAO projects where we are doing kind of customizations of Earth map. So you can see, you can put your own data or put your own area of interest, change your boundaries and so on. So this is another option. Or if you have open data in Serbia that you can just use them, then we can just use those ones. I mean, this is not official stuff, you know, this basin boundaries are not, this is just an indication, like a best possible global product that there is.
Okay, thank you. So this application, this Earth map are under your maintenance. So you are maintaining the whole thing, or somebody else, or you're just user? I didn't get that.
No, yeah, I'm the everything basically on this. So product manager of First Map. Now we have other people working, but it's mainly me and another colleague.
Okay, thank you.
Hey, Alfonso.
Yeah.
I saw the chat. Ružica Stričević can answer the question that Gordon asked. I saw in chat.
Okay, thank you.
Shall I say? So,
Please.
okay, there is a hydrological process of making this level. So that's why this level goes from the several levels. So the whole area is level 1, like a Danube watershed. Then you can see one watershed is the Danube, and there is on a smaller level like tributaries, like level River Sava, a second level, and the third is Morava, and for example, South Morava is a fourth level, and so on and so forth.
But here we don't have a level 1. We have levels from 6 to 12, and they are divided according to size.
Yes, the level 1 is the super coarse one. Level 1 is basically all of Europe.
Yeah, more or less. But this is the way. There is a we can go even further using this map to be in several hectares, like watershed in one creek. So this map is very powerful, and you can make later on the smaller watersheds.
Yeah. Yes, basically because this, as I said, this is a WWF global product, no? So they have a limitation on processing time, you know. So I guess the smallest basin they could go without being a super complex was this level 12. You could subdivide it again, no?
Yes. It can be subdivided in much smaller watersheds.
Yeah. But I mean, for them, that will be, I don't know, super complicated at a global scale, you know? So there is something actually I forgot that we have that could be interesting. So there is one product, which is the river network, which is also based on the hydrosets. So this river network has, oh, it's too much information here. Let me see. So this is an approximation also using hydrosets or the river network. where you have different levels of rivers. Okay. So this from the level 1 to level 10. Okay. So you have from small tributaries to bigger rivers. Okay. And there is also, but again, this is quite coarse, no? It's not amazing. Probably you have a much better data in Serbia for rivers than this. Again, this is the thing, we do have limited by this earth map being global, so we don't really have a specific products for each country, because that will be like a never-ending process. That one could be interesting, I think. And then we have one that also pretty interesting. I guess you already know about this one, is the JRC, the surface water transitions or surface water history or occurrence from the Joint Research Center of the European Union. And this one is pretty interesting because you can see changes on water cover. So you can activate it here. It says surface, well, there are multiple ones, but this one is maybe the most interesting, the surface water transitions. So you can they have classified from 1984 to 2020 changes on the water cover. All right. So you see areas where, okay, it's permanent water that has not changed, areas where there is lost water that has disappeared. So water cover that has disappeared. Okay, this is normal next to the river. Blah, blah, maybe like in a river, an island that has appeared or disappeared. But they have an interesting one too, is the appearance of seasonal and permanent waters. For instance, this whole area here, where is this? South of Zrenjanin, where you have a whole area where you have now seasonal water and some permanent water. And I don't even know what this could be. Is it you have any type of rice here or something like that? Could there be rice in this area? No. Because otherwise you have seasonal and ephemeral waters around here, according to this classification. I don't know, maybe it's wrong. So what is this?
Yes, it is Tamish River. Probably yes. There are waterlogged area.
It's just waterlogged because it's a very big area. And there are planting lots of trees around here. For instance, according to this, all of these areas are ephemeral water. So you have, I don't know what this
Like
could
a
be.
fish pond.
A fish pond?
Yeah, probably.
But they're very large.
I think it's fish
No,
pond.
this is more like agriculture, some type of agriculture where you have, yeah, according to this, some water cover throughout the year. But anyway, this is something you see in the north of Italy with the rice. I don't know, like if there is anything like that in Serbia. I guess you don't have rice in Serbia, do you? Anyway, this is maybe like something interesting for you to check out this surface water transitions product, which covers all of Serbia or the world. Anyway, where you have the surface, water surface that has not changed, like permanent or whatever, and then the changes. So areas where you have new permanent, for instance, like they build a lake, sorry, they build a reservoir, lost permanent, seasonal, new seasonal. So this is all areas that, according to this, have changed in the last years. Well, anyway, you can investigate yourselves, I guess. But there is also, well, all the areas where they find new permanent water, what this could be, I don't know. But again, if you wanted to see exactly when this new permanent water has appeared, I don't know, this looks like a water reservoir, I guess. And this product is from 1984, so maybe it is actually very old. So even it says new permanent, according to this is new permanent water, but maybe this was built in the 80s. So even if I use the method to just draw a boundary and check the vegetation index, possibly this is quite new and quite old anyway. Okay. So again, this probably is anyway older than I can check, because we can only check, sadly, we can only check from 2000. Okay, so our first year to use the vegetation index approach is 2000. Well, yeah, and from 2000 is anyway, it's quite low. You have again, in the satellite images, the most interesting for you should be this one. Well, we also have the Sentinel-1, which is actually really good at finding water. But this Sentinel-1 image, let's say, it hasn't been updated for a while. So Sentinel-1 is an optical, a radar sensor, and radars are very good to find water. So anything you find here in black is going to be water cover. But for some reason, it doesn't say the date. So the date, there's no date. But bene, I'll fix the date on that. Date water. Sorry. Anyway, I don't know. Look into the surface water thing. I think it could be of interest for all of you, maybe. And again, the basin part, if it's something, I mean, it's really not like a UN FAO definition of basins. It's just something that it's available at global level. So if there is anything better for you, or you have any access to something that could be more useful, then we can just, or you could even upload yourself. You see the process that I just did to upload the images, sorry, the shapefile before, then you can do this yourself as well. Okay, here using the Landsat, going back to that reservoir, so you can actually see images from 84 with Landsat, with the Landsat GreenSG pixel. So you can see in 99, this is already built here. 92. '92 is not built because again, you see that it will be black if it's water cover, it should be black. 95 is already there. So anyway, but probably you could just look in the internet about this. But this is interesting anyway, that you can see the 94 is when they built it, and in 95 is when it was filled already with water. Look. So anyway, the idea is tomorrow, from my point of view, is if you guys could think of some good ideas around your areas, or I don't know, like maybe like play a little bit with Earth Map. I mean, we haven't really covered all of the products that we have, because for instance, we also have the products on the landforms and elevation and slope, and all these products that of course for irrigation are very interesting, no? So this is also data that we have in Earth Map on different maps derived from these elevation models. Okay, so you have in the landforms, you have like a classification of the land according to the data elevation model. So you can have, like, for instance, classification by slope, if it's in a valley, a cliff, mountains, and so on. This could be interesting for the irrigation planning. Okay. We also have the slope maps. Okay. Where you can have a classification on the slope percentage. We also have the elevation maps. And again, for when you do like a analysis for one polygon, you can also, of course, that reserve is not very good. But if I get, for instance, a hydro set, sorry, a basin level, maybe the level 12 again. I could do like maybe like a classification here for this basin. Okay, on this one. What is your this elevation? The geophysical analysis of the basin. So you get data on the average elevation, the average slope, the classification by slope, the distribution of the elevation on the basin. Like this is like the histogram. You can also do the landforms. Here, landforms process. As well, and how is distributed the type of land in the basin. So you, for instance, that you can see how much is the area that could be available for irrigation according to the type of slope and so on. I don't know. I guess I'm not as I said, not an expert on the irrigation side, but I guess this is type of information that you will need as well for the planning. Again, this is the landforms product is something you can understand more from the classification from the paper. So as a product. After I know this in FAO they are using this data for some of these integrated land use planning maps. So this could also something that could be of use. But I guess maybe you even have a very detailed digital elevation model in Serbia. No.
Yes,
Would you
we
please
have.
repeat your question, please?
That I guess you do have a really detailed digital elevation model because the one we use is the standard SRTM model. Sorry, the SRTM digital elevation model, but you probably have better.
I think in a survey service, Republic Survey Service, I think they have.
Republic Geodetic Authority have.
Exactly that one. No, because I remember we work in Serbia. Or I worked with Serbia a while ago, and I remember they have quite good maps. But anyway, so if you want to, and if that's okay for you, it's already 12 o'clock. So maybe it's time to move on. But for tomorrow, I think to make also this as useful as possible for everyone, then maybe we should try to come up with some idea of how this could be used for your work, or like anyway, even an area of interest that you have, so we can practice a bit on that area of interest. I can even try to find some area of interest in Serbia. I don't know.
Thank you very much, Alfonso. A great training as usual. Thank you for completing this first session of the Earth Map training. Again, appointment is tomorrow at 9 o'clock sharp, as usual, very sharp. We will go through more practical uses. I think Alfonso's point is quite clear. It doesn't need or require any enhancement. So thank you very much, Alfonso, for this first session. Again, the meeting is recorded and will be made available as soon as possible in the usual link. Giovanna, if you could tomorrow put in the chat the link where all the documents are available, that would be great. So for today, I would like to close the meeting, thanking the Water Management Directorate first for giving us the possibility and opportunity to share this very important tool. And of course, to Alfonso for his usual assistance and support in this kind of training. Colleagues, with that, thank you very much. I hope you will have a great rest of the day, and I'll see you tomorrow morning at 9. Thank you very much. Bye-bye.
Ciao. Bye-bye.
Bye-bye.
Bye.
Bye bye.
Bye
Bye.
bye. Bye.
Bye bye.